In this video, we'll take a look at solving systems of equations. The first section, section 5.1, is solving a system of equations in two variables. So the types of problems that look like two linear functions, ax plus by is equal to c, and then dx plus ey is equal to f. So two linear functions have, in terms of x and y, to the power of 1. So linear functions have a graph with your lines, and there are three things that can happen when we solve a system. So solving a system means find the x and y coordinates that work or that are true for both equations. So three things can happen. The first thing that can happen is there's one solution. Your lines intersect each other and intersect at a point. That's called an independent system, and you have one solution in the form of an xy coordinate. An inconsistent system means that your two lines are parallel, they never intersect, so there are no solutions. And the third thing that can happen is that your two equations are multiples of each other, and you end up graphing exactly the same line, and those are called a dependent system. So we can solve systems of equations in three different ways. The first way is that we can solve by graphing. It's not the most efficient way because you can't always see where the two equations intersect. But in this case, it worked out in this example that if you graph 2x plus y is equal to -8, use any method. In here, we've solved for y and graphed it using slope-intercept form. You could also use x and y intercepts or plot 2 points. Then the graph x minus y is equal to -1. We solve for y. We graph the two, and then notice they intersect at the coordinate -3, -2. So the solution to that system is the coordinate -3, -2. So that would be an independent solution because there is a solution. So what we do instead is usually use algebraic means instead of a physical picture because it's a little bit easier in all cases. So the first one is called solving by substitution. Solving by substitution means take a look at your system and solve either your first equation or your second equation for just x or just y. So in the first equation, I have y by itself. So if you solve the first equation for y, you get y is equal to -2x minus 8. And the other equation, x minus y is equal to -1. Then substitution means we're going to substitute whatever y equals in the first equation. We're going to substitute that for y in the second equation. So I end up with x minus, put parentheses because we're going to substitute, -2x minus 8 is equal to -1. Notice you've got an equation with one variable, and now you solve for x. So I get x, distribute the negative, plus 2x plus 8 is equal to -1. Add, we end up with 3x plus 8 equals -1. Subtract 8 from each side. 3x is equal to -9. Divide both sides by 3. We end up with x is equal to -3. So once you get one coordinate, the x coordinate, take your answer and substitute it back in your one of the either the two original or the one you just solved for y to get the y coordinate. So if x is -3, then y is equal to -2 times -3 minus 8. 6 minus 8, which is -2. So we end up with this answer that the system is independent and it intersects at -3, -2. So that's the same system that we graphed up above. And now we're going to solve the same system one more method called addition. The addition method means take a look at your equations. I've got 2x plus y equals -8, x minus y equals -1. And what we want to do when solving by addition is we want to add the two equations together and make sure that either the x or the y variables cancel out. In this case, it's set up that if we added together y, negative y, they would cancel. Usually we have to multiply by something. You can multiply an equation by any number that you want to in order so that when you add them together, something will cancel. In this case, we don't need to. We can add the equations. 2x plus x is 3x. Y minus y cancel each other out. Negative 8 plus negative 1 is negative 9. Divide both sides by 3. X equals negative 3 again. And then substitute back into one of your two original, or it doesn't matter which one. I'll pick the second one this time. Substitute negative 3 for x minus y is equal to negative 1. Add 3 to both sides. We end up with negative y is equal to 2. Divide both sides by a negative. Y is equal to negative 2. So whether we graphed, solved by substitution, or solved by addition, we got exactly the same answer. So now we're going to try, take a look. Notice that they all were an independent system. Now we're going to go ahead and solve and see what happens. Solve using any method. I'm going to go ahead and limit it to the algebraic methods because graphing would be complicated on here. So the first equation, solve using any method. We have 2x plus 3y equals negative 16, and 5x minus 10y is equal to 30. Well, we would like these two to cancel out when we add them together. So we have to, you can multiply or divide either equation by anything you want to. This is kind of an extreme case, but if we want to eliminate x's, this is a 2x, this is a 5x, we could multiply the top equation by 5 to end up with a 10x, and multiply the bottom equation by negative 2 to end up with negative 10x, and that way when we added the two equations together, that x's would cancel. So let's see what happens, let's see what we get. So we get a calculator just to do some arithmetic. Multiply the top equation by 5, we end up with 10x. 5 times 3 is plus 15x is equal to negative 16 times 5, which equals 80. So that would be negative 80. So they're multiples of each other. The bottom equation I'm going to multiply by negative 2. Negative 2 times 5 is negative 10x. Negative times negative is a positive 20y. Negative 2 times 30, negative 60. Now when we add the two equations together, the x's will cancel. 15 plus 20 is 35y. Negative 80 plus negative 60 is a negative 140. Divide both sides by 35. 140 divided by 35. If all goes well, it goes in evenly. It goes in evenly. Y is equal to negative 4. Once you get the y coordinate, substitute in either one of the first two equations, original two, to get x. So I'm going to take 2 times x plus 3 times y, I just ended up with negative 4, equals negative 16, and solve for x. So 2x minus 12 equals negative 16. Add 12 to both sides. Divide both sides by 2. X is equal to negative 2. So this turned out that we had one solution again, and these two lines share the solution, negative 2, negative 4. All right, so the two examples we've looked at so far have a solution. What happens when you're solving to let you know that there's no solution or there's an infinite number of solutions? So let's take a look at the next example. We have x equals 9 minus 2y, and x plus 2y is equal to 13. This is set up pretty nicely for us to use substitution because we have x equals something in the first equation. So I'm going to take 9 minus 2y and substitute it for x. So I get 9 minus 2y plus 2y is equal to 13. Oh, now notice in our equation, negative 2y plus 2y cancel each other out, and I'm left with the variables canceling, and 9 is equal to 13. So that's a false statement. So that tells me that there is no solution. So when your variable cancels out and you're left with a false statement at the end, no solution, so that means these two lines are parallel to each other. So the lines would be parallel if we graphed. Oops, I better spell my math words right. All right, last example is we've got x plus 3y equals 2 and 3x plus 9y is equal to 6. So I'm going to go ahead and solve this one by addition. Let's see, if I want to eliminate x's, I would multiply the top equation by negative 3. So when we do that, we end up with negative 3x minus 9y is equal to negative 6. The second equation, 3x plus 9y is equal to 6. When we add these together, notice that everything cancels. I'm left with 0 is equal to 0. That's a true statement. So your variables canceled, but you were left with a true statement. That means that the two lines are the same line. So that means there's an infinite number of solutions. So when we go back up to the beginning, that's called a dependent system. If we were to graph those two lines, they would be the same line. One's a multiple of the other. Okay, so those are all the things that can happen with systems of equations in two variables.